So welcome back. Let's continue our part 2, how to design and conduct a discrete choice experiment. So in this session, we will briefly talk about what are the key steps and key components involved in conducting and implementing a discrete choice experiment. So briefly speaking, there are 5 major steps involved in conducting a DCE study. After we know what our research questions are, the next step is to define relevant attributes and attribute levels that will help us understand individuals' preferences toward a certain product or service or policy. So after we have the attributes and the attribute levels that we will use to describe the product or service of our interest, the next step is to generate an efficient discrete choice experimental design. So basically, this design will be a matrix where we outline the different combinations of attribute levels that we use to describe a certain alternative. And after we have the efficient design, then we can convert our design into a survey or questionnaire format. Because as you remember, we talked about that discrete choice experiments are attribute-based survey measure of value. So we have to have a survey format in order for us to proceed with the data collection. So after we construct the survey, the next step is to collect data from our respondents. And after we finish data collection, the final step is to analyze the DCE data we collected and to interpret the results. So in this session, we will going to discuss each step one by one, and I will give you a sample. I will give you some examples using a sample project. So first of all, let's just suppose that we want to understand the job preferences of university graduates. We want to know what they value, what are the important considerations they have when they look for their first job. So here is our research question. What do university graduates value the most about their first job? So this is a very appropriate research question to be answered using a discrete choice experiment, because here we want to know how they make their job decisions, how they make trade-off, and what are the most influential factors to their job choices. So to identify attributes and attribute levels that we will use to describe different job opportunities, there are 2 major approaches. The first approach is that we can rely on systematic literature review. We can take a look at prior literature and prior studies and see what they have identified as important factors to employment decisions, employment choices of university students. For example, we may find that prior study has already identified that flexibility, the salary level, the employee support, job training, the location of the job, and maybe career advancement opportunities. These are all very important attributes or factors for individuals when they consider a job opportunity. Besides systematic literature review, we can also rely on focus group interviews, collecting first-hand data to understand the preference of individuals, of our stakeholders in a real-life settings. So for example here, to identify which factors are influential to university graduates when they make their job decisions, we can conduct a focus group interview or in-depth or semi-structured interviews with university graduates to further understand their considerations, what they value, their attitudes, and their opinions about looking for their first jobs. And after this, after collecting important insights from these different approaches, we will then be able to identify the most relevant and important attributes and their corresponding levels. So for example, here we already outline 4 attributes and their levels as these in this sample project. We can have the employee career support, whether a company offers sufficient support to their employee so that they can further and advance their career. like job training, the mentorship, the coaching opportunities. And we have two levels under this attribute, yes and no. The second attribute we have is salary. So we have three different levels to describe the salary level of a job opportunity. Can be 10% lower than average, the market average, and 10% higher than market average. So here we want to see if individuals, if university students are willing to make trade-off between their expected salaries and other attributes that are influential to their job opportunity, to their job decisions. Here, the third attribute we have is flexibility of a job. So we have three levels: low flexibility, medium level, and high level flexibility that individuals can have in their job positions. And the final attribute we have is the location of the job, which has been identified by prior studies as a very, very important considerations that people have when they make a job decision. So the location also has three attribute levels: rural areas, suburban, and urban areas. So we want to identify which one of these attributes is the most important for university graduates, for fresh graduates, when they look for their first jobs. So here are some principles that you need to keep in mind, you need to take into consideration when you define attributes and their attribute levels. Basically, there is no restriction of how many attributes that you can use in a discrete choice experiment. But of course, the more attributes you have, the more complex the experimental design will be. So usually we should keep our number of attributes fewer than 10 attributes. So to keep our experimental design as simple as possible. And the second principle is that we should try to avoid conceptual overlap between two or more attributes. Sometimes when we identify attributes, some of our attributes may look very similar, or they have some like overlap in terms of their concepts, in terms of their meaning. So these can easily confuse our respondents, and we will not be able to isolate the interaction, the effects of that one particular attribute from other attributes. So we should try our best to make sure that there is no conceptual overlap between our attributes. And finally, regarding the number of levels that we should have for each attribute, also there is no restrictions in terms of how many attribute levels we can have in discrete choice experiment. But as I mentioned, if we have too many levels, if we have too many attributes, the experimental design will be very, very complicated, and it will be quite challenging for your respondents to manage the questionnaire. So to make their job easier, to make their life easier, and also to make sure that you can capture the most authentic, accurate responses from your participants, the attribute levels should be within 2 to 4 levels. And also when we develop levels, we should also make sure that those levels could reflect the range of situations that the respondents might expect to experience in a real life setting. So after we have our attributes and attribute levels, next thing we need to do is to design our experiment, design our DCE study. In most cases, there are two different types of experimental design involved in a DCE study. The first is the full factorial design that covers all possible combinations of our attributes and attribute levels. For example, in our sample project, we have a total of 4 attributes, and there is one attribute with 2 levels, and there are 3 attributes with 3 levels. So a full factorial design will result in 54 profiles in total. And if we adopt a 2 alternative design, which means that we will combine two alternatives in each choice set, then we will have a total of 27 choice sets for each respondent. That is a lot of work. That is a lot of questions to be involved in a questionnaire. So in most cases, when we have a relatively complicated experimental design, we will go for the second option that is called a fractional factorial design. So this is considered as more efficient because it's less time consuming and it's less it gives less burden on your respondents to complete a DCE questionnaire. The fractional factorial design means that we only use a subset from our full combination of all these profiles. We only select a part of these profiles and we combine them, we convert them into an experimental design, and we only use part of these to present to our respondents. So usually, it's suggested that we should have fewer than 18 choice tasks for each respondent to reduce their burden and cognitive efforts. Because if we have more than 18 choice tasks, the respondents, very likely that your respondents is just going to randomly pick an alternative, randomly pick an option without really looking into the details, looking into the attributes and attribute levels that we use to describe a scenario, to describe a product or service under examination. So ideally, we should keep the number of choice tasks in our questionnaire to be fewer than 18. However, sometimes, even though we use fractional factorial design, that even though we only before we talk about the block design, here are the two criteria that we should bear in mind, we should take into consideration when we use a fractional factorial design. So in order to have a perfectly efficient design that can help us to reflect the preference of individuals toward a certain policy or product or service, there are two major criteria. One is balance, and the second is orthogonal design. So to have a balanced design, we want to make sure that each attribute level appears equally often within an attribute across all of our choice tasks involved in our questionnaire. This is called a balanced design. And the second is orthogonal design, which means that each pair of attribute levels should appear equally often across all pairs of attributes. If we can meet these two criteria, then we can say that we have a perfectly efficient design. Even though we only use a subset from all possible profiles, still we can get very, very good estimation from this fractional factorial design if we meet these two criteria. So to have this, of course, we can do this by hand, we can calculate this manually, but in most cases it's very challenging, it's time consuming, so we will rely on some software or R programming to help us to generate an efficient design, and we'll talk more about the technical details of how can we come up with the efficient fractional factorial design using our package in a very easy and efficient way. So sometimes, even though we have the fractional factorial design, even though we only use a subset from all possible combinations, still the number of choice sets can be considered as too many. When this is the case, when you want to further reduce the burden on each respondent, you can consider using a block design. So a blocked design means that we split our experimental design into different parts, and usually these parts are equally sized, each with same number of choice sets. And when we split it into different blocks, we can randomly assign our respondent to one of these blocks so that the number of choice sets, the choice tests they are receiving, is significantly less than the non-block design. For example, if we have 24 choice sets originally that we want to present to our respondents, but we think that 24 is just too many and we want to further reduce their burden, we can consider splitting the choice sets into 3 blocks. So here, the number of block we set is 3. If we do this, then we will split the 24 choice sets design into a 3 blocks design in which each block only contains 8 choice sets. So which means that when we actually start our data collection, each respondent will only need to answer 8 choice questions. They will only receive 8 questions as their main DCE task rather than 24 choice sets. So it's significantly much more time effective and time efficient compared to the previous design. So after we have our experimental design, the next thing that we need to do is to convert our experimental design into a survey format. So we need to construct a survey in order to facilitate our data collection process. So usually when we prepare the questionnaire, there are several important components that we should involve. The first is an introduction. You should briefly tell your respondents what your research questions are, what you expect them to do in this questionnaire. And of course, you need to introduce the task here, what you expect them to perform. And you need to briefly talk about the logic, the key things involved, the key components involved in your experimental design. What do attributes mean, and what are they expected to do? They are expected to pick an option between 2 different products. Here, I present an example from one of our previous projects. You have alternative meat product A, and you have alternative meat product B, and each was described by different attribute and attribute levels. So you need to introduce these different levels and different attributes to your respondents so that they can understand what you are doing here. So after the introduction, the next step is then you can present your respondents with the actual DCE choice task. That will be something look like this screenshot here. You present them with a scenario and you ask them which product do they prefer to buy. It can be product A and product B. And sometimes we also include an opt-out option to resemble the real life situations so that the consumers, the respondents, can always choose to buy neither of these 2 products. And after the main DCE content, you also can collect some demographic questions about your respondents, their gender, their age, their employment status, marriage status, if you think that those information are important for you to do some further to perform some further analysis. And of course, at the end of the questionnaire, you should also thank your respondents for their efforts and for their time they put in this experiment. So after you have this survey, next step is to implement the survey and to start your data collection. Before you do that, it's suggested that it will be a very good practice to pilot test, to pre-test your questionnaire. You can recruit like several stakeholders, several respondents, like 3 to 5 respondents, to help review your selection and definition of attributes, to ask them if they can understand the choice tasks you set in the questionnaire, whether they can understand those attributes and attribute levels, and whether they think the number of choice tasks is too many for them to handle, like in the questionnaire. So after you get some initial thoughts, initial ideas from your pilot testing, you can then further revise and refine your questionnaire to improve your questionnaire. And after you finalize your questionnaire, you can administrate the questionnaire in different channels through different approaches. So one of the most commonly used approach is to distribute your questionnaire through online platforms such as Qualtrics, SurveyMonkey, or even Google Forms. Or, of course, you can conduct face-to-face interviews to implement your questionnaire. So after you finish your data collection, the next very important step is, of course, to proceed with the data analysis. But before you can start your data analysis, there's one thing that you need to do, that is to convert your data sets into a format that can be analyzed by relevant R packages that we will use later. So we want to make sure our data set is organized in an appropriate way that can help us to perform data analysis later. So here on the left-hand side, I present the original data set. So this is something that you will get if you directly you export your questionnaire results from Qualtrics. This is the Excel form that you will get from the website directly. It's very, very messy, right? So in order to proceed with data analysis, we need to transform our data set into something that looks like in the screenshot on the right-hand side. So we should have our respondent ID from 1 to 200, for example, and we need to specify which block that your respondents are assigned to. In this example, I only have one block, so they all get the same value on the block column, that is 1. And next, you need to organize their answers to each choice set like this. So Q1 refers to choice set 1, Q2 refers to choice set 2, and you need to capture their answers in each column. For example, here you can see, let me do this. You can see for respondent 1, his or her answer to the first choice task is alternative 1. So they pick product A rather than product B in the first choice set. However, the respondent 2 pick product B over product A in the first choice set. So that is how you should organize your data set in order to make sure that it can be analyzed by our packages later. So after you get your data set ready in a format that can be recognized and analyzed by R, the next step is to proceed with your data analysis. The most commonly used estimation model in discrete choice experiments is the multinomial logic regression. It's also known as the conditional logic model. So this logistic regression is a classification method that generalizes logistic regression to multi-class problems. And most importantly, one of the key features of this regression is that it relates the probability of choice among 2 or more alternatives to the features of their attribute levels that are used to describe the alternatives. So you can capture how individuals make trade-off between or among attribute levels and which attribute is most important for them when they make such decisions. So here I would like to use a very quick example to further illustrate the key steps involved in conducting a discrete choice experiment. Here I'm using a PIA study that's it's a paper published in the Journal of Ecological Economics. So this paper, this DCE study, focuses on investigating individuals' preferences for sustainable seafood. So here are some contexts. Salmon is one of the most successful farmed fish species in terms of the production growth. So most of salmon products that we now consume are actually farmed rather than wild products. However, unlike the wild fish products, the farmed fish species, they do not have a very serious equal label for the farmed seafood. And this problem has become more apparent in recent years. In order to address this problem, an ASC equal label was created to fill this gap, to allow fish farmers to indicate that their product is actually sustainably produced with is up to certain standards and with a credible label. So for farm fish products with this label, you will know that their products are produced in an environmental sustainable way. So here is the research objective for the authors that implement these DCE studies. They want to know the effects of these label, whether the consumers value this label or not, and whether having this label will impact upon individuals' purchasing decisions. And they also want to test whether the effect of having this label is large enough to negate the disadvantage of not being wild products, because we know that people always prefer to consume wild products than consuming farmed fish species. And the third research aim of this study is to examine how the ASC equal label for farm salmon compared with the equal labels for wild fish. Which one is preferred, is more valued by consumers, by individuals. So the first step, as we mentioned, now they have their research questions. The first step they need to do is, of course, to identify relevant attributes and attribute levels that they want to include in their DCE study. So how they do this, like what we mentioned before, they also conducted a systematic literature review to look into factors or attributes that have already been identified by other scholars. And then they also conduct a 10-person focus group interview to further validate to the identified factors and to further understand what individuals value when they make a purchasing decision. So after these two steps, they come up with 4 attributes, and each with different levels. The first is the price of the salmon products. So under this attribute, there are 5 different levels. And the production process, whether the salmon is a wild species or it's a farmed product. And the third attribute is sustainable certification. It's whether this product has certification, has an equal label on the packaging or not. So there are 2 levels: no certification or has certification, either MSC, the label for the wild products, or ASC, the equal label for the farmed products. And the final attribute they included is processing. That talks about the format of the fish products. So also has 2 levels: frozen fillet and the fresh fillet. So after having this, the next step is to consider the experimental design. How can we incorporate these different attributes and different attribute levels into an efficient DCE design? So the scholars decided to adopt a blocked fractional experimental design. So they have 24 choice sets in total as their fractional experimental design. And they randomly allocated these 24 choice sets into 4 different blocks, which means that they have 4 different versions of their questionnaire, and they will randomly allocate 1 version to each respondent when they proceed with their data collection. And each questionnaire only contains 6 choices. And this means that each respondent will only need to answer 6 questions in the main DCE content. So this is very, very manageable in a way for the respondents, because they only need to answer the question for 6 times. So it's not a lot of work compared to other DCE designs. So this is a a sample DCE choice set that is presented to respondents. Here, they have two products, product 1 and product 2, and each was described by different attribute and different attribute levels. Then the respondent need to indicate which product they prefer to buy based on this information. But of course, they can always choose to buy neither of these products if they found these two options not attractive at all. So after finishing data collection, respondents were, here to collect the DCE data, the scholars decided they want to randomly select respondents from consumers shopping in the markets. So rather than having an online survey implemented using Qualtrics, they chose to do this face-to-face by interviewing respondents and ask them to indicate their decisions towards different choice tasks. And after their data collection, here are their estimation results. So here is the results table that is nicely organized in their paper. So for us, the most important information that we should pay attention to is coefficient. Here we can look at the coefficient for different attributes, and we will look into those coefficients with significance, with very small p-values. Here for price, we can interpret these results as the respondents significantly prefer cheaper salmon products, because here the coefficient for price is negative and it's significant. So they prefer cheaper products significantly. Similarly, we can also interpret the results for frozen. That is the format of the salmon product here. As the coefficient is significant and is negative, so we can interpret this as respondents significantly prefer fresh salmon products over frozen products. And similarly, if we look into the attributes certification, the ASC certification or the MSC certification, we can interpret the results as respondents significantly prefer certified salmon products because both coefficients are positive, which means that respondents they dislike having no certification at all. They prefer certified salmon products. And because the size of coefficient of MSC, that is the coefficient for wild products, is much higher than the ASC label, we can consider that the certified wild fish is the most important factor in consumers' purchasing decisions. And taking all this into consideration, we can conclude that sustainability concerns are more important than quality concerns. Despite that, the price attribute, the frozen attributes are all significant, but the size of their coefficient is much lower than the coefficient of the certification, which means that sustainability is a more important consideration that individuals have when they make a purchasing decision. So this is the example of how can we design and implement a discrete choice experiment from the scratch. And in other tutorials, I will further illustrate how can we use our programming language to help us with the experimental design and the data analysis. So thank you very much, and I will talk more in the tutorial session.